All right, welcome back to Fortner Industries. Today we are going to do some minor surgery on this great little caterpillar stem toy. So the idea here is you get an introduction to programming with these links that plug into the back of the caterpillar, and you put a bunch of links in a row and make a little program. Interestingly, it uses USB for the connection, which is sort of neat. But the problem with this thing is it has one volume setting, and that is ear-piercingly loud. So today we are going to put in a quieter sound setting with a resistor in the speaker, and we'll put it also on a switch so we can either mute or have a reduced volume, because it is really, really loud. You can hear it across the house. I don't know why kids' toys are often so loud. Kids can hear better than adults can, and this is ear piercing for adults, so I don't know what they were thinking with that, but we're gonna fix it. So to start off with, I took out the batteries, and I'm just gonna go at it with a screwdriver here to the 4 screws. So this thing's pretty neat. It has side-to-side motions, so you can make it steer around forward, and then a little speaker module, and you can get other modules to add on to the program. It's a great introduction if you have young children, toddler age, and I don't know, maybe up to 5 or something, for understanding how a program will step through each step in a line. All right. Those screws out, and then this should just come off. Alright, we have a bunch of connections into the head. I believe there is some lights and the head moves up and down. But all of these connections are soldered. And the head also works as a bump sensor, so if it runs into the wall, it won't keep trying to power in there. Interestingly, right here, you can see there's an optical encoder for tracking the steps of forward motion. It has a little drive wheel here, and there's a very simple ganged steering link here. It's just looks like a servo that moves back and forth for the forward steering. You can see that there. But because it's a program and it will step forward, I think each link steps forward a couple feet. You need an encoder to know where it's at, and it's interesting that they use an optical encoder for that. Okay, so what we're going after here is the speaker, which if I show that, it's up in the top up there. And some people just clip the wires of the speakers, so there's no audio, but I don't really have a problem with the audio. It actually sounds decent. It's not an obnoxious tone or anything. It's just way too loud. So I think I am going to desolder. It's going to be easiest if I desolder at the speaker, I believe. Actually, let's just take the speaker out, and that probably tells us all we need to know. And I have a special helper here watching over my shoulder, make sure I don't destroy her toy. Okay. So there's just 2 little screws for the speaker, and then it comes right out. And we actually don't need to mess with any of the rest of this, so I'm not going to worry about all the connections that are soldered onto here. We can just work with this part right here. So this is a very simple, basic speaker. Okay, next I'm going to desolder this connection to the speaker here, and I have a bunch of resistors. I read online some people said that a 100 ohm resistor worked well. but I'm going to try it out. I have a whole selection here, so we'll find out which one has a nice volume, and then I'll get into what the circuit is for adding in the switch. So let's desolder this right now. This thing was a little expensive as far as soldering irons go, but it was so worth the investment. I was tired of using cheap soldering irons that never really worked very well, and this Hakko has been fantastic. It heats up very, very fast, and it's been very, very reliable. So if we just desolder here. All right, that's that pin done. And then next up, we will try some resistors. All right, we have a 100 ohm resistor here. Just touch that in there. And this doesn't need to be fancy. This is not how I will leave it. I'm just going to test the volume here real quick. Touch that. And next, put in the batteries. Is that a good volume?
Sounds great.
Okay, after some quick testing and wife approval, we are good with the 100 ohm resistor. It's very, very quiet, but you can still hear and play with it, so it'll be much less annoying. So we'll go ahead and take the batteries out. And then I mentioned earlier I wanted to have a switch, so we could switch between the muted and off, and basically all I need to do for this is use one of these little micro switches I got. These tiny little guys, and I'll just have the connection soldered across here like this. So you'll have the speaker and the resistor with the switch in the middle of them. Now, since this wire is up here, I'm going to need to make a longer lead, and then I'm going to put this switch in the bottom of the battery compartment here, so that it is unobtrusive and doesn't get in the way of anything. And I'm going to do that cut with a rotary tool. So let me see where that cut needs to be. If there's any easy place I can put this switch that won't be a problem. Okay, so for this, we are going to put it on this wall here. I'm going to make a small cut deep enough in there that I can fit the switch and it won't interfere with the battery. And the idea being, if you ever want to turn it on to full silent, you can just take out that battery, flip the switch, and then it won't make any noise. And that won't impact the power on-off switch here. So I'm going to take out the rotary tool. And I'm going to need to change the bit. This burr cutting tool should work well for what I need to make. And before we dive in, let's make a small mark for our target here. All right, here we go. Perfect. So you see that that is now in there. And then I'll just need to solder the wires to that. So to test out the circuit, I'm going to need a little bit of wire. Typically I like to use old Cat5 wire for this. You get a lot of wire for just a short length, and Cat5 wire is so cheap that you probably already have some laying around in an unused Ethernet cable somewhere. But I'm going to look through my wire spares and see what I can dig up. Be right back. Alright, welcome back. I got my workspace cleaned up a little bit here, and we are ready to put in the switch. So I heated up my hot glue gun here. I have this battery operated one, Ryobi, works really well. And first off, I'm just going to add a little dab of hot glue at where my new resistor is, just to keep that pushed down out of the way, and then also insulate that connection. So that is kind of hard to see, but it's back in there. And I'm just going to squeeze some hot glue on that. Alright, so that part is done. Now the next part is getting this switch in place here. So you can see the hole right there that I've cut out for it. And I also put a battery in, so I make sure that I don't put the switch in there such that you can't get at the battery anymore, can't get the battery out. So right about there should do it, and then you'll just be able to use a pen to click the switch back and forth if I put it in there at that angle. And we're just going to use hot glue for this as well. Something like right there should work really well. Just to finish it off. And we'll set that aside. I really like using hot glue for projects like this. It is a really good structural bond that I've used for a lot of things, but then you can just heat it up and it's reversible if it needs to be. So you can see here that the caterpillar is working really well at a much more reasonable volume. I really do like this toy overall. It's a great way to understand the basics of programming. Just put each of the little motions in a line there, and then it will repeat that program. And I'd like to see Fisher-Price do even more of these things, but maybe with the volume control next time. So that'll about do it for this video. Thanks again for watching. I have a bunch more projects in the pipeline, and I'll catch you in the next one. Thank you.